Welcome to another video from explainingcomputers.com. This time we're going to check out Bullseye, the latest edition of Raspberry Pi OS. This contains quite a lot of new features as well as technical changes under the surface, most of which are very positive indeed. However, there are issues with camera support, and so I'm also going to talk about those, which is why this is quite a long video. Right, I thought we'd jump straight in, and so here we are in Raspberry Pi OS Bullseye Edition. As you may know, Raspberry Pi OS is based on the Debian Linux distro, which receives a major update every 2 years. And the last Debian update occurred in August 2021 and was named after Bullseye, which is the horse in the Toy Story movies. And so here we now have a new edition of Raspberry Pi OS named after the same animated character. Just to let you know, right now I'm running Bullseye on a Raspberry Pi 400, but across the video we'll be testing it out on several different Pi models. And what you see here is pretty much how Bullseye looks straight out of the box with this lovely new sunset clouds background. I really like this new background, although I have made here a few changes to scaling and things like that just so it reads better on video. So if we go to the web, there we are, we can see that Bullseye can be downloaded from raspberrypi.com and manually written to a microSD card using your favourite imaging software. Or you can create a new card using the Raspberry Pi Imager application. Note that, whilst it's possible to upgrade an existing Raspberry Pi OS installation to Bullseye via the terminal, the Raspberry Pi Foundation does not support such upgrades and recommends a clean install. And I've already had first-hand reports from people who've had problems doing an upgrade rather than taking the clean install route. As usual, with all things Raspberry Pi, everything is extensively documented. There's a page here which announced the new operating system, and there's masses and masses and masses of content here, as well as a picture of Bullseye, the horse after which the operating system is named. And there's so much here, I'm not going to go through all of it in this video. So rather, I'm going to pick out the things which to me seem to be the most important. Firstly, on the technical side, the toolkit used to create the graphical user interface has been updated from GTK+2 to GTK+3, and there's also a new window manager called Mutter. And all of this really matters because the practical implication of these changes is that things look and feel a bit more modern here in Raspberry Pi OS Bullseye, with, for example, a little bit of shading here and there and some animation effects. And if we right-click the panel at the top, like that, and we look at panel settings, you'll see there's quite a lot more here we can adjust, including a size setting for the icons on the panel. And this is in addition to the settings we've got over in Raspberry Pi OS. We look at the appearance settings. Where are we in preferences and appearance? Almost lost it there. We've still got the settings over there where we can change things just to be different sizes, large, very large, etc. We've also got the setting now here in panel settings for these icons. I do like that. I do like to have control of the icon size in the panel. This said, the new Mutter window manager does use more memory than the previous OpenBox version, and so on Raspberry Pi models with less than 2 GB of RAM, OpenBox is still used. Next, a notification manager has been added to the panel, which currently shows a message if, for example, we eject a USB drive like that. We'll eject that drive and we get a notification to say that's happened. And we also get notification messages if, for example, the power supply voltage is too low. And if you're wondering, we can go into panel settings like this, back in there, and somewhere in here we can turn off notifications. It's somewhere down there. There we are. We don't have to have notifications on if we don't want to. Also making use of a notification manager is a new graphical updater, which checks for updates on each boot, and if there are updates, it displays a panel icon, which we can see up here, to tell us updates are available. And we can click to install and either show the updates, have a look, see what we want to do, or if we want, we can just do what most people will probably do and install updates. And this will now launch a graphical updater, which we've not had on the Pi before. So we now don't have to go to a terminal to do an update, and we don't have to go and check if there is an update. It's all handled by the new notification system with the new updater. And this is a really good development for the Pi it moves it forward to be like other operating systems. Returning to technical changes, a very big update indeed is both the display and camera drivers have been changed. Specifically, the Linux kernel mode setting or KMS driver is now used to generate the display, with a Linux library called libcamera used to control the camera. These changes mean that two very important and previously closed source proprietary pieces of code have been replaced with open source alternatives, and this will make it easier for developers to work with the Pi. However, and it's a very big however indeed, changes to the camera driver in particular have major practical implications that will not be welcomed by many users. And so I'll return to this subject in depth later in the video. Other changes of note are that if we look in games, over here, we will see under games, we don't see Minecraft and we don't see Python games because they're not compatible with Bullseye, so they can't be there. However, on the very positive side, we've got a new version of the Chromium web browser included here in Bullseye, and wait for it, this has been optimized for hardware-accelerated video playback. So we'll be taking a closer look at YouTube playback in Bullseye in the next segment of the video. Something else we're going to be checking out is the fact that in Bullseye, the default turbo speed has been increased from 1.5 to 1.8 GHz for the most recent Raspberry Pi 4 models, which is a very cool thing indeed. And finally, it is worth noting that, like most operating system updates these days, Bullseye is heavier and more demanding on the hardware than what it's replacing. And so it'll be very interesting to see just how practical it is to run this latest version of Raspberry Pi OS on the less powerful Raspberry Pi computers. Greetings! Here I am back again, and we're now running Bullseye on this 2GB Raspberry Pi 4. And it's a fairly early 2GB Raspberry Pi 4, so the CPU speed here will not be increased by running Bullseye. And I've picked this Raspberry Pi 4 for our YouTube playback test on the basis that if YouTube plays OK on this board, it should work on any Raspberry Pi 4 and indeed the Raspberry Pi 400. So let's go across to the desktop, and here we are, and I thought we'd just have a look in some of the resource things here. We'll look at Task Manager just so you can see what's going on one of these boards. Remember, this is a 2GB Raspberry Pi 4, and you can see that we've got only about 186, 87 megabytes-ish of memory used out of our available 2GB. So although Bullseye is heavier than previous Raspberry Pi OS distros, it's still very light compared to most Linux distros. And of the memory here, a little bit will be used for the GPU. Let's just look here to show you that. Look under Preferences and Raspberry Pi Configuration. Bring that up. And if we look under, I think it's Performance, isn't it? There we are, look. You can see 76 megabytes of memory has been allocated to the GPU. And these are the default settings. I've done nothing to this copy of Bullseye other than install it and do a few changes to scaling and things to read better on video. So let's run up the Chromium browser. Very exciting. Little animation there as it comes up as we get in Bullseye. And you may note here we've got plugins here and 82640fi was already installed to help us with browser-based streaming media playback. I've not installed that, it was there by default. So let's go to our YouTube clip, my standard playback here, my standard sample YouTube file. Bring it up and play it. Hopefully it'll play. It'll take a second just to sort itself out. There we are. I think it's going now, and we'll full screen it as well. It's having a think. There we are. And we'll just check whilst it sorts itself out. We really are in 1080p. I don't like using the auto there because it never sodding works. There we are. And it's properly in there in 1080p. And we'll bring up Stats for Nerds as well. And there we are, all set. And as you can see, YouTube playback is pretty good. We have got a few drop frames as things settle down, but once things do settle, YouTube playback is pretty good actually. It's not absolutely perfect, but it's highly usable. I've been testing out YouTube playback on different versions of the Raspberry Pi using Bullseye for about 10 days now. It's very good. I've had it connected to my television, watching YouTube, no issues at all. So this is a definite win, a definite plus using Bullseye on the Raspberry Pi. Right, I've now hooked up the lovely Raspberry Pi high quality camera to our Raspberry Pi 4, and I've also switched out the microSD card for one containing the previous edition of Raspberry Pi OS, which is known as Buster. And if we go across to the desktop, here we are. I want to show you a couple of things here in Buster before we return to Bullseye. Firstly, if I run up a terminal like that and I enter this command here, which was waiting in the buffer, raspy still and a bit of syntax, it will bring up a preview of the camera like that, and it'll take a picture, which will be called PicJPG, as you can see from the code. There we are, that's what it's done, that works absolutely fine. And if we also go to a piece of Python code I've got sitting here in the Genie Programmer's Editor, this is a piece of code from my recent Raspberry Pi time-lapse video. If we run this code, it will again bring up a preview and it'll start taking frames at whatever frame rate we've specified in the code. So as you can see, this all works fine using a camera in Raspberry Pi OS Buster. So let's close this down. We'll Control-C that and we'll close down that as well. And we'll just shut down the Raspberry Pi, quickly switch over the microSD cards and boot back into Raspberry Pi OS Bullseye. And here we are, and if I now go to a terminal and we enter the same Raspberry Pi still commands like that and press enter, we get commands not found. And this is because the commands Raspberry Pi still and the associated command Raspberry Pi vid only work with the old camera driver. And so in Bullseye, to perform the same function, we need to use one of the new libcamera commands. Specifically, this command here will give a preview and take a picture, so we'll enter on that. And that will work. It'll bring up a preview with slightly different picture settings, but it'll bring up a preview and take a picture. Which is fine, except for the fact that every Raspberry Pi camera tutorial written since the Pi was introduced in 2012 uses the old camera driver terminal commands. Even more seriously, if we go to our Python code, let's go across here and launch the Genie Programmer's Editor, and it should bring in by default the code we had earlier, my time-lapse code, and if we run this code, it doesn't work either. And it doesn't work because it brings up this, no module named PyCamera. And this is because the Python PyCamera library does not yet support the new camera interface in Bullseye. Now, I should point out that the Raspberry Pi Foundation have documented all this very well indeed on their own web pages. So let's just go to the Chromium browser and go to the relevant page. Here we are, and if we scroll down here, you'll see this is the camera page for the Raspberry Pi. It introduces the Raspberry Pi cameras, talks about the different interfaces and commands associated with them, and it's got this big box here explaining the differences between the old and the new camera stacks. There really is a great deal of useful technical information on this page, but what it basically confirms in broader terms is that if you install the latest version of Raspberry Pi OS, then all of the existing educational resources out there on the internet for using a Pi with a camera will not work without alteration, and none of the Python code they contain can be run at the present time. So, to be clear, the code in all of my Raspberry Pi camera and robot videos will not work, and of course it's not just about me and my resources, it's about everything. If we go to Google, let's go to google.com, like that, and if we do a search for example, Raspberry Pi camera Python tutorial like that, and do enter, we will discover quite a lot of documents. If I zoom up a bit, you will see it's over 6 million documents come up on that search, which is quite a lot of results. And admittedly, lots of these will be duplicates and won't exist and all that kind of stuff. But even so, it makes the point that the success of the Pi has been built on a large body of resources published by the support community and which are not compatible with Bullseye. Now, on November the 17th, a blog post was posted by the Raspberry Pi Foundation also on this particular issue. Let's go to that as well. It's down here. This came out a little bit later than the actual release of Bullseye itself. Here we are, a post all about the Bullseye camera system. And I delayed making this review of Bullseye until this promised post had been published. But sadly, what this confirms is that there's currently no camera support in Python, although a new module called PyCamera 2 is in development. And this post also reports that none of the official Raspberry Pi cameras work in Bullseye on the new Raspberry Pi Zero 2W. So within the space of 2 weeks, a new Raspberry Pi model and the latest edition of Raspberry Pi OS were launched, but you cannot use them together with a camera. Now, in this post, it is pointed out, I think back at the top, let's just go back up there, that the previous edition of Raspberry Pi OS Buster, is still available to download if, as they say, you're not ready to use Bullseye, which I find to be somewhat of an understatement if you've just purchased a Raspberry Pi Zero 2W and you intend to use it with a camera. Now, OK, as the post says, some of these things, like support for cameras on the Raspberry Pi Zero 2W, will be fixed shortly. But we are clearly stuck with a new set of camera commands in the terminal, and that's going to cause confusion for a very long time, and there's no timescale for Pi camera being implemented in Python. So right now you can't use a camera in Python in the latest edition of Raspberry Pi OS, which I think is very strange. This is not a good development. The foundations of the Pi's success have always been backwards compatibility and the community educational resources out there on the internet. But sadly with Bullseye, these foundations appear to have been trashed, at least for non-technical users who rely on educational resources and want to use their Pi with a camera. Now, let's turn to something more positive, which is the increase in the maximum processor speed that Bullseye provides for the latest Raspberry Pi 4 models. Specifically, the CPU's turbo boost speed is increased from 1.5 to 1.8 GHz on all Raspberry Pi 4 boards that have a dedicated switch mode power supply for the SoC core voltage rail. Such boards can be identified by the triangle of black components between the power and HDMI connectors that look like this. So, if your Pi 4 has these components, it will get a 300 MHz turbo boost in Bullseye. However, if it looks like this, it's an earlier board and will continue to have a maximum clock speed of 1.5 GHz. Inside this Argon 1 case, I've got an 8 GB Raspberry Pi 4, all of which have got the switch mode power supply, so this Pi will run faster in Bullseye. And to prove it, let's first go to the desktop running Buster, the previous version of Raspberry Pi OS, on this Pi, where we're going to launch a terminal, and I've installed a utility called sysbench on this Pi using the command sudo apt install sysbench. And it's important to let you know the version of sysbench. If I do that command there, it'll show us the sysbench version, which in Raspberry Pi Buster and previously is sysbench 0.4.12. Anyway, I'm now going to run a sysbench command so we can check out the speed of the machine. I'm going to run this command here, which will factor prime numbers to a value of 10,000, and we'll just let that run through. And there we are with a little jump forward in time. We've done that test in 23.33 seconds. So let's use the magic of filmmaking to go across to Bullseye running on the same 8 GB Pi, and we'll again launch a terminal. And initially again I'm going to show you the version of sysbench I've installed, and here it is version 1.0.20. And the big difference is the new version of sysbench, which installs in Raspberry Pi Bullseye and beyond, is constrained by time when you run it rather than by events, at least by default. And so to run the same test, we have to put in this syntax here. So again, we're doing CPU max prime equals 10,000, but we've actually got on the end here, I'll just pull this out so you can see it more clearly. We've got a threads equal 4 as we had before, because there's 4 cores on the Pi, but we've got time set to 0, so it's not constrained by time, and events to 10,000. So if we run this, very exciting, see what the result is going to be. And there we are, we've got a result of a 20.98, but effectively 21 seconds, compared, if you remember, to 23.33 running Buster, the previous version of Raspberry Pi OS. So clearly we get a measurable increase in speed running Bullseye rather than the previous version of Raspberry Pi OS on a recent Raspberry Pi 4. As we can see on the download page, the recommended edition of Raspberry Pi OS Bullseye remains 32-bit. Code is included to enable individual applications to access up to 4 GB of RAM, so allowing all of the memory to be used on an 8 GB Pi. Even so, given that all recent Raspberry Pi models have a 64-bit processor, staying with 32-bit is a little strange. However, it does mean that the recommended version of Bullseye remains backwards compatible with all Raspberry Pi hardware. And so, to finish up, I thought we'd spin up Bullseye on a Raspberry Pi 1B and on the original Raspberry Pi Zero 1W. To start with the Raspberry Pi 1B from 2012, I've got it hooked up here as you can see, and still this is in many respects the most exciting Pi. I love all the connectors on this board. I love the journey it took so many of us on. This is still my favourite Pi in many respects. Anyway, let's go across to the desktop where it's running Bullseye, as you can see, and it does work. It is a little sluggish because the Raspberry Pi 1B has got a single core processor running at 700 MHz, so not massively powerful, but we can run the system. There's a bit of a lag in the menu, but it does work. Let's go to accessories and run up the task manager, which you can see takes a little bit of time to come up. It'll get there. Give it encouragement. It's arrived. Look, that's good, isn't it? And we can see that things are working okay. We've got half a gigabyte of memory, 512 megabytes of memory on this Raspberry Pi 1B. The very early boards had 256 megabytes, but this is the later one with half a gigabyte. And things are running okay. Let's just run up also something else. Let's say run up, I don't know, the calculator. I'm picking quite small applications, and even so, they take a little bit of time to come up. It's going to get there in a second. Can we have the calculator, please? Go on, you can do it. It's having a little think. There we are, the calculator and the task manager at the same point in time. And I should of course point out that there is a light version of Raspberry Pi OS Bullseye without a desktop, which is what you probably would want to run on this board if you're still using it for various purposes today. So, let's go across to the Raspberry Pi Zero 1W, which is a Pi you very much might want to run Bullseye on. It's a very good low-cost projects board. And if we go across to its desktop, it is pretty much, in terms of performance, very similar to the Raspberry Pi 1B, which is not much of a surprise because the Raspberry Pi Zero 1W is very similar to a Raspberry Pi 1B, except that its single-core processor is clocked at 1 GHz rather than 700 MHz. So let's just bring up Task Manager here, see how rapid that comes up. Should be a little bit faster on the Raspberry Pi 1B. I think that seems to be working okay, doesn't it? There we are, like that. And we'll see how fast does a calculator launch on this. We've got a new test, how fast a calculator launches. And again, it's going to take a little bit of time, isn't it? You can run Bullseye on these lower power Pis, but it's probably not the best thing to do. And in case you're wondering, a Raspberry Pi Zero 1W does not have Ethernet, but I've got it connected up to a small hub to give me a network connection because I got so fed up waiting for Wi-Fi to sort out all the updates for the board. So there we are. We've tested out Bullseye on lots of different versions of Raspberry Pi, but these days I'd recommend running an earlier version of Raspberry Pi OS if you want a graphical desktop on one of the earlier single-core Raspberry Pi computers. Today is the 20th of November 2021. And I've now been testing out Raspberry Pi OS Bullseye on lots of different models of Raspberry Pi for about 10 days. And from that testing I can report that it's a very solid, a very stable update. This said, as you probably gathered, I'm not terribly happy about the changes to the camera stack, the camera driver. And I understand why the changes have been made to make it easier for developers to work with a camera on a Pi by making it open source, but I also find it fairly extraordinary that right now the current edition of Raspberry Pi OS, the one you're offered in Raspberry Pi Imager, the one that's most easily available to download from the website, the version of Raspberry Pi OS that new users will end up using, that version of Raspberry Pi OS has got no Python support for a camera at the current time. Now, I understand that in computing you do get moments of inflection when you have to move to new technologies and you get issues of backwards compatibility. And I guess that Previously, we haven't had one of these moments really with a Raspberry Pi, a point where lots of older resources are simply not going to work. So we've been quite lucky with the Pi over a long period of time. They've really focused on keeping backwards compatibility, which is why perhaps I'm so surprised we haven't got that issue. Now we've now got this backwards compatibility problem building up around camera use. And I guess what I would have done, and no one asked me, and maybe hindsight is a wonderful thing, but what I would have done with Raspberry Pi OS Bullseye would have been to have called it something like Raspberry Pi OS 2, to make it clearly distinct from Raspberry Pi OS 1, which I know can't be supported forever in terms of Debian updates, but if we'd seen on the website Raspberry Pi OS 2, Raspberry Pi OS 1, same things in the imager, and it's been made clear that if you go for the new version there will be backwards compatibility issues, that I think would have made the transition and what's going on that row a little bit easier. Anyway, that's my view. I'm sure you've got views as well. You'll already be typing them away down in the comments. I look forward to reading all those inputs on this topic. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe. And I hope to talk to you again very soon.